So hello everyone, welcome back to my channel. My name is Sahil Sawant and I am currently pursuing MTech in Computer Engineering at VJTI Mumbai. I completed my bachelor's in Electronics and Telecommunication Engineering from VIT Pune and I have been exploring algorithms, system design, AI and competitive coding for many years. In this video, the first lecture of Advanced Algorithms playlist designed for students preparing for interviews, GATE and anyone who wants to build a strong CS fundamentals. This lecture is going to particularly focus on these skills only. So what am I going to cover in this series? So in this series, we will go beyond basics and learn how algorithms are designed, how to analyze the algorithms, performance, greedy, divide and conquer. We will also include dynamic programming as the syllabus covers everything. Then we will look at the graph algorithms, then NP completeness, and we will also gather resources from real world applications which are used in Google search, Gemini, Maps, AI, and other operating systems as well. So our goal is basically simple: to turn our community or us into someone who thinks like a problem solver, not just someone who memorizes the code and goes in the exams, just pastes it as it is and yeah, we have got marks. No, this should not be how the coding is performed. It should be the lines that are not only memorized but understood and then told forward to the examiner or the interviewer as well. So beginning with our first question. So what is an algorithm? Let's start from the basics. So algorithm, we can understand it like it is a step-by-step procedure to solve any particular problem that is given to us. It is like the brains of any program. So code, it is not only just the implementation, it is also what encompasses the program, the problem that is being solved. So whether we are like sorting numbers, which we will be looking in further videos as well, finding the shortest path or training a machine learning model, everything, it requires a certain logic behind it, and this logic is, when it comes in coded form, it is known as an algorithm. So to keep it in simpler words, an algorithm decides how fast, how accurate and how efficient the solution is ultimately going to be. So let us understand this using real life examples. So let's take this example as if I am searching for friend's name in my contact list. So what would I do? I would just scroll down one by one until I reach my friend's number, or just directly jump to the first letter of that alphabet, which is like the binary search logic that I'll be performing, and the previous one scrolling down one by one, that is the linear search logic that I'll be performing. So same problem, different algorithm. So one solution to one problem can have many different solutions, but from those solutions we'll have to choose one which is technically and viably important to us, which will give us the results faster and more accurate. So algorithms allow us to choose the best possible methods for a given problem. Understanding the logic behind algorithm provides us with the best possible mean for the given problem. So what can be called a good algorithm? A well-designed algorithm has these 5 important characteristics. So first and foremost, which is the most important, it is a clear input, a clear defined input, and it should provide a particular well-defined output as well. Then the algorithm should be definite, the steps must be precise. The fourth one is fitness. The algorithm should always terminate after certain number of procedures, certain number of iterations. And fifth is effectiveness. Every step should be doable in reasonable amount of time. It should not go around in loops. It should not infinitely give as many answers. It should not give incorrect answers. So these are the universal rules that are followed in every field, from AI to computing. All these fields require algorithms to be developed in these formats only. So now the most important question that arises in algorithm field is how do we compare exactly these two algorithms? To analyze the algorithm's performance, we use two concepts, the complexities. One is time complexity and the other one is space complexity. So time complexity is how fast the algorithm runs, and space complexity is how much memory the algorithm is utilizing. For example, we would have like heard over people saying linear search has complexity of O of n, binary search has complexity of O of log n. So what are these? These are the scenarios that help us determine which is an optimal algorithm. So now moving forward, we'll be looking at priori versus posteriori analysis. When analyzing algorithms, we generally use these two kinds of approach. The priori analysis is done before we run the code, while the posteriori is done after we run the code. The priori analysis is also named as theoretical concept, so which is performed before the execution of the code. It is independent of the system, the hardware or the compiler, anything, and it uses mathematical models. And example of priori analysis is the big O notation or big theta notation, recurrence relations. These are examples of priori analysis, which are like important concepts from gate perspective, not from interviewer's perspective. But it is better that we understand this concept. These concepts are also used in masters while the students are pursuing masters as well. So moving from priori, the posteriori analysis, which is also known as empirical analysis, which is when after the code is implemented. So the code is first of all run on the real machines, then the actual execution time is taken, and it is checked on how it is affecting the CPU, RAM, OS, then the compiler optimization, and all these things are checked, and a benchmark system is formulated. So this is practically used in big companies, the ones who are managing servers, let's say for example Nvidia's, the Oracles, and these things are being used in these companies only. In simpler words, priori means prediction and posteriori means observation. Both are important. The one which helps you understand theory, while the other tells you how the algorithm performs in the real world. So now guys, this is for the introduction to algorithms, and I guess now you understand what algorithms are and why they matter and how we are going to analyze them as well. From the next video, we will delve into asymptotic notations, the big O, big theta and big omega notations, which are also known as the language of algorithms efficiency, which basically we have covered in priori analysis. So if you found this video helpful, hit the like button, share it with your batchmates, and subscribe for full advanced algorithm series. So see you in the next lecture.